Hi, I'm Dan Olds on behalf of Hyperion Research and Inside HPC. And this is going to be a special treat. We have Merle Giles, who we're going to be talking to about his experience in HPC. So, how did you become involved in HPC, Merle?
Sometimes I'd like to say I couldn't even spell HPC when I got into it, but I had been at the University of Illinois running the executive MBA program for the business school. I'm a business guy myself, had an MBA from that very program, ended up running it for a while, leaving because we'd moved it to Chicago. But anyway, fell into the position at NCSA at the university to be the director of what they called at that time the private sector program. So built an industry-facing HPC services operation right here in Illinois.
Okay. So, can you kind of summarize your background in HPC?
So we learned that there were barriers to access and education and all sorts of the classical things that we've talked about for years as a student sort of the business models. The research machines are wonderful, but not always accessible. And we had, as partners in our industry program, a fair number of manufacturers, just being here in Illinois and some Eastern U.S. facing companies and so forth. The manufacturing business is largely led by commercial codes that can do simulation.
Sure.
And the commercial code guys don't often get access either. So we actually began to focus on how to help the commercial side of what manufacturers care about. So we built a system ourselves with different kind of access models and had it for industry only. And it began to get very deeply into the problem sets with these companies, many of which were Fortune 100, and learned a ton. And we like to think we helped a lot.
And this is before the Fortune 100 started building out their own internal HPC?
Oh no, the Boeings of the world, the Fortune,
The
the large
Boeings.
one.
Sure.
Yes, the big boys have been doing this for 50 years in one form or another. They all had high interest in HPC and in fact ran clusters of their own and so forth. But as an HPC center, our attitude was if we can't run HPC better than you guys, then we shouldn't be in the business. So that was our goal is let's run this better and let's work on some things on how to break barriers in this space.
So what are the biggest changes that you've seen in HPC during your career?
So HPC for so long, for decades maybe, even from the early 1980s when the NSF systems came about, HPC has been this high-level, lab-level access to do some of the world's toughest problems. And that's a research problem of its own, but if you step back just a bit, the companies, manufacturers, others, biotech, and so forth, also have exceedingly difficult challenges, but not always at the scale that those large machines are built for solving. So the access becomes kludgy code maybe, or we did a lot of work with Fluent because we had all sorts of a manufacturing community that cared about Ansys Fluent, for instance.
Sure.
But they didn't have people to help hold their hands to actually make this stuff better. So we did research projects. We tried to build systems that were very good to do this. So the changes in HPC have been that second tier, what we learned in the second tier of HPC, just below the big research labs, is exceedingly important in the commercial space.
Okay.
So some would not call it, it's not research HPC. So really that next tier actually brought some problems that were pretty difficult. And then that tier of build the cluster on-prem has now moved a little bit and shifted to cloud. So that's some of the biggest change. The supply chain in manufacturing, for instance, can access cloud HPC in ways that would beat what they could do on-prem. An example is the whole HPC emphasis that's really special at Microsoft Azure. Amazon does it a different way, but Azure's got InfiniBand, for instance. So the business model shift has been greater access, and in theory, and indeed I think in practice, more access farther down the supply chain in a domain that was once dominated by large companies.
Makes a lot of sense. So given that, where do you see HPC going in the future? And is there anything you're particularly excited about or concerned about?
HPC as a narrow slice of computing, as one of the pillars of computing, is truly high performant. But I once walked into a manufacturing company in Peoria and in my months into my job and said, "Hey, if we could help you speed up your simulation by 100x, wouldn't you just love us?" The answer was no.
No.
And I'm thinking, oh my goodness, what did I just say? And so it got us into a conversation about workflow. And building the models at a manufacturing company actually take more time than running the simulation. So if we could help with the model building, actually it'd save more time overall, which is plenty expensive with personnel, than simply running, I say simply, running the simulation. And of course the simulations are often, seeking out parameters and trying to fix your design. The other thing I learned from that company, sort of related, was those guys are given just 2 weeks out of the entire design build equation, the workflow inside the company, to add their special sauce to the design. I mean, the designers are moving on in 2 weeks, whether you've done your stuff or not.
Wow.
And it turns out that if you want to simulate oil in a differential, and since it's incompressible fluids, the math is exceedingly difficult. It would take a month to run a single job because it would only run on 32 cores.
Oh, wow, that's incredible.
It's like, but gee whiz, these airplane engine guys are running on 1,000 cores with the same code. What's the difference? When my guys will say, well, it's simple. It's the difference between compressible and incompressible fluids. Well, okay, who knew? Who knew?
Yeah.
So that's the difficulty of the physics. And if that oil in a differential simulation takes a month, but you're only given 2 weeks to get, add something to the design, HPC stays in the R&D basement forever.
Good point.
And never gets out, okay? Occasionally, it's a long-term process. So we think about, okay, we're going to outcompete and those kinds of things. But in reality, if you can't do it in 2 weeks, you have to do it another way. So the old school manufacturers will do it another way. So part of the challenge is to help the code, help the users spend more of their time doing engineering instead of wrangling access to the code and trying to do things HPC-like. So there are lots of things that actually changed that rubric. But what I learned, and I think is a change in this industry, is that as we move HPC up beyond research and into operations, it drives ROI because operations is where the money is. R&D is a fixed budget, which everybody wants to squeeze. So this workflow matters. The TRL system, for instance, and you go from research to different kinds of research, and POCs and demonstrations, and one day you're going to the moon. As we can move up that chain, HPC really does matter, but we don't often deploy it on the operational side of a company.
So it's not deployed in the right place yet with a lot of companies.
So Tom Lang at P&G, for instance, would claim that HPC was never a boardroom conversation because it was so focused on R&D. So today's world, AI is a boardroom conversation. Well, AI needs high performance computing, but just of a different kind.
Yes, totally agree.
So if AI drives operations in a business and we can have computing to speed that up, everybody wins. And in a Procter & Gamble situation, for instance, Tom would say very publicly that their challenge is in the last mile. Delivery to wherever you go. You can make the product, you can make the product better, you can do all sorts of things. But this distribution, it is a big deal. And so part of what I'm seeing today is a desire to get information as to what's going on under the hood and to where that vehicle is going.
And to optimize.
And optimize that. That's right. That's right. So it's a big data problem. It's really a high performance data analytics if you could get there. But the challenge is how to get that done. But AI has brought computing to the boardroom in a conversation in a way that HPC historically had not.
In the example you're using, it's a traveling salesman's problem on steroids.
It is. And real-time data analytics now is coming about in ways that can give some insight beyond batch analytics, for instance. So I'm a fan of the movie Ford versus Ferrari.
Yes.
With one of the most memorable parts of that movie being when they put Post-it notes on the car and drove it around the track pretty hard to find out how the wind was affecting the suspension. Real-time analytics offers the Post-it notes. In ways that few other things can do. If you come back, you park the car, you take apart things and look at it and say, well, what went wrong? And the Ford guy is saying, it's doing something to me here. I got to fix it. And the classical mechanics cannot fix it. Ergo, the Post-it notes. They came up with something.
Yeah.
So those are the biggest changes in this space that I see is how do we offer Post-it notes to people if we actually use operations as the target? And now we're talking edge computing. We're talking 5G, doing some things in IoT that have never been done before. But do we go into the R&D basement and do batch analytics to try to figure out what's happening in real time on a manufacturing floor? Same story as classical HPC. If that's what happens, that's what you have to do to gain insight, but you actually have to put it into rows and columns to figure out what and know what to ask for.
Yeah.
It's back to an R&D project. So
that's a good point.
If it's R&D, if it's a research approach to an operational problem, we've got a gap.
And we have to bring it down to that on the street operational need. That's the key.
That's where the money is.
Yes.
And
that's where the benefit is.
So let's think about an HPC deployment. At some point, the OpEx becomes larger than the CapEx. The capital expenditure to buy the nodes and the CPUs in the first place can at some point, let's just call it a year, and maybe you bought it to hold for 3 years, the cost to run those CPUs is going to eclipse how much you paid for them in the first place. So, do we have HPC systems instrumented to be able to optimize the costs, the operating costs? Not typically. We don't watch what goes under the hood and don't have all the data to do that. And if you do it in a classical batch analytics approach, you might not even be asking the right questions because you don't know what's happening under the hood. So if you have real-time analytics in the form of Post-it notes, you may have more insight and can lower your OpEx costs and affect operations.
You know, I love how you brought it back to the Post-it notes. And I think that's a great point to end on and keep in people's mind. You've got to find those Post-it note places in your operations.
That's where the biggest money is. And if you can save money on the operational side, you can fund research in better ways.
Absolutely.
It pays for itself.
Becomes a virtuous circle.
Absolutely. Absolutely.
Great. Well, thank you so much, Merle. I really appreciate your time. And I know that our listeners and watchers are really going to enjoy this. Thank you again.
Dan, it's a pleasure. Thanks for having me on.